Hello, everybody. It is wonderful to be back. I know that you're probably just as excited as me to get right back into mathematics. I know that the one person that you want to see right after your 3-week break is your math teacher. So I am very excited as well. Let's get straight into this. I want you to download the Word document that is associated with this. It is the skeleton notes that we usually fill out in class. Either you can have it on a window by your side, that way you can follow along a little bit easier, or you could print it out where you can actually fill it in. Either way, please have that at the ready so you can be ready whenever we have a test or a quiz. Now, we're going to be talking about trigonometry. You haven't heard about trigonometry since geometry, so it might be a little bit scary to get back into it. But don't worry, we're going to start from the beginning, and we're going to discuss everything that these trigonomic functions deal with. The first thing I want to go over is, what is trigonometry? What does it deal with? Well, trigonometry deals with right triangles, pretty much exclusively with right triangles, at least at the beginning. So everything that we're going to be discussing is dealing with a right triangle. Now, if you forgot what a right triangle is, if you look at this triangle right over here, you can see I have circled the right angle, this 90-degree angle. As long as a triangle has one 90-degree angle, it is a right triangle. So everything we're going to discuss today deals with these types of triangles. If we look down here, we have words and symbols. Now, the symbol section here is the meat of what we're going to be talking about. Sine, cosine, tangent, and then over here we have cosecant, secant, and cotangent. Whenever they're written out, we're only going to be using the abbreviation. We're never going to use the entire cosecant or cotangent. We will just say CSC or COT. Now, what is this theta, this symbol right here? That is telling us that is the angle that we are working on. So anytime you see theta, that just means whatever angle we are working on. For instance, if you look at this right triangle, this 3, 4, 5 right triangle, we have theta right over here. That means we're going to be working with this angle instead of this angle. So right now, the angle that we're talking about is this one right over here. I want you guys to write down something. This is something that will save your life on any test that you have on this subject. In fact, whenever I am taking a trigonometry test, even down to this day, I will write this down at the top right of my page. Here it is. It is SOH, SOH, CAH, TO, TOA. SOHCAHTOA. SOHCAHTOA. This will save your life. SOHCAHTOA. Now, what does this mean? This means that if I have a sine function, this SO part right over here, SOH, this stands for sine, is equal to the opposite divided by the hypotenuse. So sine is opposite over the hypotenuse. What does opposite mean? Well, if we look at our angle that we have right over here, the opposite angle is going to be the one that we can draw an arrow across the triangle to. If you notice, we can't draw an arrow across the triangle to the 3 because it's connected to it. We can't draw an arrow across the triangle to the 5 because it is connected to it. The only arrow that we can draw across the triangle is to that 4. So opposite is referring to the 4. Hypotenuse. What is the hypotenuse here? Hypotenuse is always going to be the longest edge of the triangle. It is the edge that is opposite of the right angle. So 5 is going to be the hypotenuse here. So that leaves one thing, the adjacent side. That is going to be this 3 over here. So we have 3 key words that we're looking for here, which is opposite, adjacent, and hypotenuse. So that would be opposite, adjacent, and hypotenuse. Let's write those down on this triangle. It really depends on this angle that we have here. If we have an angle here, the 4 will be our opposite angle. So let's write that down. The 4 is going to be OPP. That's going to be our opposite side. 5, on the other hand, that's going to be our hypotenuse. So we're going to call it HYP. And now 3, that leaves one thing left over, and that is going to be our adjacent side. So we're going to call that ADJ, adjacent. So now that we have everything labeled, we can actually fill out our examples. So here we have the symbols, and right under that we have the examples. You can see that sine equals 4 over 5. Where did we get 4 over 5? Well, this is going to be opposite over the hypotenuse. We know that because of our SO in our SOHCAHTOA. Sine equals opposite over the hypotenuse. So that's going to be sine equals the opposite, which is 4. We have labeled it, over the hypotenuse, which is 5. We've labeled that as well. So let's continue with our 3 main trig functions, sine, cosine, and tangent. We're going to go to cosine. That's where the ka comes in. C-A-H. Cosine equals adjacent over the hypotenuse. So we're going to have 3, because we have labeled that, divided by our 5, which is our hypotenuse. Cosine equals adjacent divided by our hypotenuse. TOA, tangent. TOA. What do we think this stands for? Well, this is going to be tangent equals opposite over adjacent. So let's do that. Tangent of theta equals the opposite, which is 4. Okay, right. Divided by 3, which is our adjacent side. So 4 divided by 3 is our tangent of theta. That's what tangent of theta actually equals. Let's go down to our cosecant, secant, and cotangents. These are arguably easier than the first 3, only when we've actually filled in our first 3, because all we have to do is take whatever values we had for our sine. Our cosecant is just the reciprocal of it. So instead of 4 over 5, it is 5 over 4. Sine and cosecant are connected. Now let's look at the next connecting trig functions. Cosecant and secant are connected. They too are reciprocals. So instead of our cosine of theta being 3 over 5, our secant of theta will be 5 over 3. We just took the reciprocal of this. Now, tangent of theta and cotangent of theta are also reciprocals. So instead of 4 over 3 for our tangent of theta, we get 3 over 4 for our cotangent of theta. Now, that is what we are doing at the moment, so this is all you have to remember how to do. It all stems from SOHCAHTOA. Let's move on to an example here on our next slide. So here we have a triangle. It is 17, 15, 8, and notice it's labeled A, B, and C. A lot of triangles are going to be labeled A, B, and C, or it's some kind of lettering of the such. What we need to find out is what angle are we using, and then I want you to label your triangle opposite, hypotenuse, and adjacent. So see, we are using this angle right over here. So we need to find out a way to label our triangle opposite, adjacent, and hypotenuse. So first of all, let's find our hypotenuse, because our hypotenuse is going to be the same every single time. That is going to be our longest edge, which is also the one that is opposite from the right angle. So we know that this is going to be 17, and we're going to say 17 is our hypotenuse. We'll just call it HYP. You could also just say H, that is fine as well, but for dramatic effect, we're going to write the abbreviation all the way out. Now we're going to find our opposite side. So our opposite side is the only side that we can draw an arrow to across the triangle from our theta angle. So if we look at our theta angle and we can say, oh, look at that, we can start drawing an arrow to our 8. That is opposite of our theta. So we'll call this our opposite angle or opposite side. Now we're going to find our adjacent side. There is only one more side left over, so that one's easy to find. But we can also think of it's the one that's connected. That's not the hypotenuse. So this is going to be ADJ, adjacent side. So we're going to find our 6 trigonomic functions for this triangle. I would like you to write all of this out. We're going to say sine of theta, and that's going to equal, oh man, what does that equal? Well, we have to write out our SOHCAHTOA. So, SOHCAHTOA. SOHCAHTOA. So that means sine is going to be our opposite side divided by our hypotenuse. So let's write that down. Sine of theta is going to equal our opposite divided by our hypotenuse right there. Now we have our next one to write down, which is cosine of theta. We're going to write that down as well. Let's preemptively write our tangent. Cosine of theta is going to be our adjacent divided by our hypotenuse. So our adjacent, let's write that down as A divided by our hypotenuse. And then tangent's going to be our opposite divided by our adjacent. So opposite divided by our adjacent. I like to color code things. You don't have to color code things on your paper, but it makes it easier on the screen to follow everything. Now, we have the 3 trig functions. We have to remember that they have those 3 connecting ones as well. First, we have our cosecant. We call that CSC. Cosecant of theta is going to equal the reciprocal of our sine. So that's going to be hypotenuse over the opposite. Now we have our secant of theta, and we also have our cotangent of theta. And we're going to fill all of these in. First, our secant is the reciprocal of cosine, so that's going to be our hypotenuse over our adjacent, and our cotangent is going to be the reciprocal of our tangent, so that's going to be adjacent over our opposite. Now we have everything that we can possibly need, and we're just going to fill things in. For instance, our sine of theta, opposite over hypotenuse, we labeled everything on our triangle. So let's just use our opposite, which is 8, divided by our hypotenuse, which is 17. So that's going to equal 8 over 17. 15 over 17. Now our next bit is going to be our opposite over our adjacent. So that's going to be our opposite, which is 8 over our adjacent, which is 15. Now to go to the cosecant, secant, and cotangent, it's just everything flipped over, and let's just fill all of those things in. Okay, here we have 17 over 8 for our cosecant. We have 17 over 15 for our secant. And last but not least, we have 15 over 8 for our cotangent. This is it. Now, if these things could be simplified, I do implore you to actually simplify these, but I don't believe any of these fractions actually can be simplified. So sine of theta, cosine of theta, tangent of theta, all equal these fractions. All 6 trigonomic functions are written out like so. This is the way that I would prefer you guys to do it on your test. Let's move on to the guided practice. So now it says find the values of the 6 trigonomic functions for angle B. Angle B is the other angle here. So how does that change our triangle? I'm not going to do this for you, but I have copied the exact same triangle that we had from the previous question down to here. Now, it's saying find the values of the 6 trigonomic functions for angle B. Notice that A is labeled as theta. The problem is that now they're asking us a different question. They're saying that use theta no more. Instead, change theta to being at angle B. So we're not going to use our theta here anymore. We're going to now use it up here. We're going to call this angle theta. So how does that change things? Well, remember, our hypotenuse is always going to be the same. So our hypotenuse is always going to be the longest edge, the one that's opposite of our right angle. Our hypotenuse is going to be 17. H, Y, P. That's always going to be our hypotenuse. But changing our angle theta does change our opposite and adjacent sides. If you notice that the angle being at B now, it changes it to where I can't draw a line across the triangle to get to 8 anymore, which means that I have 15 as my opposite side. So now 15 is going to be opposite, which means that 8 is now going to be adjacent. But that is it. So if you want to reverse the video and look how I did the example problem and apply it to this, the only difference is you have a new value for your adjacent and opposite. But besides that, everything is filled in the exact same way. All right, on this slide, I want to explain what the top is talking about first. We already know that when we were dealing with our sine and cosecant, they were reciprocals of each other, which means that you can actually make them reciprocals of each other. So we have a little formula up here that says cosecant of theta equals 1 over sine of theta, which means the reciprocal of sine of theta equals cosecant of theta, which is a kind of a cool thing, and intuitively we have already known that, but now here it is just written out for us. Same thing over here as we have with secant and cosine and cotangent and tangent. Now, what these words are saying is that the values for our sine, cosine, all of our 6 trig functions only depend on the angle. We've been using the sides to figure them out, but all that means is that if you have a scaled up triangle, so like a really big triangle, it's going to be the same cosine, it's going to be the same trig function values as if it was a really small triangle with the same angles. That's all that's saying. Now, in this example here, it says if sine of B equals 5 over 8, find the exact values of the 5 remaining trigonomic functions for B. How do we do that? Well, we know a few things. First of all, we know what angle is going to be theta in this example. How do we know? It says sine of B, which means that B is going to be our theta value, which means that I will write it right over here. Now, what else does this mean for us? Well, sine, if we remember from our SOHCAHTOA, SOHCAHTOA. See how this keeps on coming in handy? If you remember from our SOHCAHTOA, sine is opposite over our hypotenuse. So let's write a arrow across the triangle to find out what is our opposite side. Well, our opposite side is right over here. We're going to say OPP. What is our opposite side? Well, we know that sine is 5 over 8. So 5 must be our opposite side value. So we're going to write this down as 5. Now, what does the 8 represent? It represents our hypotenuse. So we can write down our hypotenuse right away. We can say h, y, p. We already knew where that was going to be. But now we know that the value is 8, which leaves one thing over: our adjacent side. How do we find our adjacent side? You may think it is impossible to figure out our adjacent side. But if you remember our boy Pythagoras, he can help us out here. So we're going to use our Pythagorean theorem. And everybody, the entire school year, that whenever I said a squared plus b squared equals c squared, you got it right now. But too bad you're not in class to tell me that. So here we have our Pythagorean theorem. A squared and b squared, A and b can be interchangeable. That's just going to be one of our sides. C, on the other hand, is going to be our hypotenuse. And we know exactly what our hypotenuse is, so we're just going to use our hypotenuse there. So let's fill in the values that we have. I used 8 squared for our c squared. Now a and b are interchangeable, so we're just going to choose one. I'm going to choose b. Why not? We're going to use that for 5. We're going to say 5 squared. For a, we're just going to leave it as a. A is going to be our new side right over there. I'm going to scroll down a little bit. That way we can solve out this equation and then go back up to fill it in. First of all, let's perform our squares. So first we're going to get 25. Now we're going to get 64. And now we're going to solve it out. 64 minus 25.
It's 39.
Thank you. Our last step is going to take the square root of a square. That way we can get rid of the square. So let's go ahead and do that. Square root. Square root. So now our a equals square root of 39. Now you may be asking, but wait, 39 does not have a square root, and you will be completely correct with that. We can just use square root of 39 just like it is. So let's scroll back up to our top numbers here. Over here, our adjacent side, ADJ, that's going to be square root of 39. That's all it's going to be. That's what we're going to use for these equations, and that is okay. So let's use square root of 39 in our equations here. Here we have everything written down from the previous couple of slides. Sine, cosine, tangent, cosecant, secant, cotangent. Those are all the exact same thing. So let's fill in the blanks here. For instance, sine of theta is going to be opposite over hypotenuse, or another way of seeing that is going to be 5 over 8. Now that makes sense because we already knew what it was before. It said sine of b equaled 5 over 8, which reminds me that either you could say sine of theta or you can say sine, cosine, tangent of b. Technically, they are asking you what is sine of b, But as long as you identified that b is theta, you can use the sine of theta just fine. Cosine of theta equals adjacent over hypotenuse, or square root of 36 over 8. Tangent of theta equals opposite over adjacent, or 5 over square root of 36. Cosine is just going to be the reciprocal of sine. So instead of 5 over 8, we're going to get 8 over 5. And same thing with secant of theta. Instead of getting adjacent over hypotenuse, we're going to get hypotenuse over adjacent, and that's going to be 8 over square root of 39. Last bit is going to be adjacent over our opposite, which is going to be square root of 39 over 5. All right, one more thing that I actually want to point out is that if you're able to simplify these fractions, you should simplify these fractions. And there's another thing, it's called rationalizing a denominator. If you're able to rationalize a denominator, you should do that as well. Now, what is rationalizing a denominator? We haven't talked about that in a very long time. But just so you know, if you have a square root on the bottom of a fraction, what you can do is that you multiply the top and bottom of that fraction by the same square root. And this pattern is going to emerge that happens every single time. So for instance, we have square root of 39 on the bottom of this tangent of theta fraction. What we're going to do is that we're going to multiply the top and the bottom by square root of 39. What happens? Well, the top is just simply going to be 5 times square root of 39, and the bottom is going to turn into 39. Well, how did that happen? Well, if we have a square root multiplied by the exact same square root, it actually cancels out the square root. So we just end up with 39. So our actual answer for this is going to be 5 square roots of 39 divided by 39. Same thing happens with this secant over here. If you notice, we have 8 divided by square root of 39. The square root of 39 is on the bottom, so we're going to multiply the top and bottom by square root of 39. And what does that turn into? The top simply becomes 8 square root of 39, and again, the bottom being that it's the same square root multiplied by the same square root, it cancels out the square root, and we just get 39. But besides those two examples here, nothing else can be rationalized. If it's on the top of the fraction, it is completely fine. So now this is rationalized, and we can be happy with our lives. Let's move on. Now you're going to do this one by yourself, but it's the same exact process, except this time we have tangent of b. So theta is still going to be in the same area here. We're still going to call b our theta, but now it's saying tangent. That's different than sine. Remember, our sine was opposite over hypotenuse from the so. But if we finish out our katoa, we'll find out that tangents actually opposite over the adjacent. So if that is our theta, then we have to look at our opposite, or let's label this our opposite and our adjacent side, which is going to be in blue. We are looking at those two sides. So our tangent is opposite over adjacent. So we will fill in those two sides first, and then we will find our hypotenuse with our boy Pythagoras. And then we could fill in all of our 6 trigonomic functions the exact same way as we did with the previous example.